For this example, we're looking to find the coefficient of the x to the fifth term in the Maclaurin series generated by sine of 3x. So that means because it's a Maclaurin series, we're centered around x equals 0, and we're interested in x to the fifth. So if we think about how we would build the Maclaurin, if we're interested in the x to the fifth term, all right, let's get that on the board. All right, well, what's the coefficient in front of that? All right, well, if it's x to the fifth, that means we're interested in the fifth derivative of our function. All right, so we have the fifth derivative evaluated at 0 because it's a Maclaurin. All right, if this was a Taylor series evaluated at 2 or a 7, then we'd have a 2 or a 7 right there. But because it's a Maclaurin, we're interested in the derivative's value at 0. All right, so that's the numerator of our coefficient. And remember, whatever order derivative we're taking, we need the same factorial in the denominator. So we need 5 factorial down there in the denominator. All right, so we're interested in the coefficient of the x to the fifth term because, again, there's a term before that, there's a term after that. What's this coefficient right here? Which basically means we want to figure out what's the fifth derivative of our function divided by 5 factorial. So let's find the fifth derivative of our function. Right? We have f of x is equal to the sine of 3x, and we're going to have to do a lot of chain rule here, all right, because we have the sine of an inner function. Right? So we derive our outer function, sine derives to cosine, we keep the inner function, and then we're going to multiply by the derivative of our inner function. So the derivative of 3x would be 3. So I'm actually going to sneak the 3 in right here, and we'll see why in a moment. So now we got to get to our second derivative. All right, so f double prime of x. Now we already have the 3, so that's going to be part of our derivative, our second derivative, and then we're going to derive cosine of 3x. All right, well, cosine derives to the opposite of sine, so we're looking at negative. All right, we already have our 3 there, and then when we do the derivative of the inside, this 3x once again derives to 3. So we have this 3 plus the derivative of this 3, or times the derivative of this 3, so we end up having negative 9 sine 3x. And you can see that we're going to alternate back and forth between sine and cosine as we continue to derive. And every time that we derive, again, we're deriving the 3x, which means we're going to have to multiply our next derivative by 3. All right, so going on to our third derivative, all right, we already have the negative 9. We're going to multiply that by 3, so that gives us negative 27. The derivative of sine is cosine, so we have negative 27 cosine 3x. And then we want our fourth order derivative. All right, so negative 20 is our coefficient. Cosine derives to the opposite of sine. Again, when we derive the 3x, we're going to need another 3. So that's negative 27 times negative 3, or 81 sine 3x. And then finally, we have our fifth derivative, and we multiply 81 times 3. So it's 243 times the cosine of 3x. Now we're interested in the fifth derivative's value at x equals 0. So when we plug in 0 to our fifth derivative, we're going to have 243 times the cosine of 0. The cosine of 0 is, whoops, that's, get you on the screen here. There we go, times the cosine of 0. And that's 1, so our fifth derivative is 243. So heading back up here, our coefficient will be the fifth derivative, 243, over 5 factorial. And 5 factorial is 4 factorial times 5. 24 times 5 is 120. So we could also write this as 243 over 120. And we have our coefficient for the fifth, x to the fifth, in our Maclaurin series generated by the sine of 3x. So now that you've seen this, can you try the next example, which is a cosine one, and excuse me, it starts with cosine of 2x, and see if you can come up with that coefficient.